I don't really like teaching when I'm not there, but I think you'll pick up on this pretty fast, I hope. So anyways, today you're going to be able to solve exponential equations with the same base, and then you'll also be able to solve exponential equations with unlike bases. And so let's kind of go through this really fast. I'm just going to kind of go straight into showing you some problems. And so your first problem you're going to see is when you have the same base, 3 to the exponent of x plus 1 equals 3 to the exponent of 5. And so what we're going to do is we're going to pull out those exponents and set them equal to each other to solve for x. And then we're just going to do linear equations. X plus 1 equals 5, subtract 1 on both sides, and x is going to equal 4. Again, we might see something like this, where x equals x to the 2x minus 1 or 3. Now, if you don't have an exponent, it's automatically 1. So we'll pull out 1, we'll pull out the 2x minus 3, we'll set them equal to each other, and we'll do linear equations. Add 3 on both sides, so 1 plus 3 is 4, equals 2x, divide by 2, and x is going to be 2. You also might see something like this, where 2 to the 3x equals 2 to the 2x plus 3. We're going to pull out those exponent pieces and set them equal to each other. So 3x equals 2x plus 3. Linear equations, subtract 2x on both sides. So now you're doing 3x minus 2x, and x is going to be 3. Now sometimes, well, again, we can do some example problems. Again, pull out those exponents. 2x equals 6, divide by 2, and x is going to be 3. Pull out the 2x, pull out the x plus 1. Subtract x on both sides, and x is going to be 1. And same idea here, pull out the 3x plus 5, pull out the x plus 1. 3x plus 5 equals x plus 1. Combine like terms by subtracting x, and then you can subtract 5. So 2x equals negative 4. Divide by 2, and x is going to be negative 2. I hope I'm not going too fast, but I think that is pretty understandable. Let me know if you're not sure what I'm doing here. But this is when it kind of gets a little bit more complicated, right? And so there are going to be times where we don't have the same bases. And so what you need to do is, our goal is to make the same bases, okay? And so if we have 5 to the x equals 125, we want to try to make it so it has the same base as 5. Well, right off the bat, I know 5 is a prime number, so we can't break down 5 anymore, but I do know I can break down 125 more, right? And so I do know that 5 times 5 times 5 will be 125. So let's do the opposite and pull out 125 and do 5 to the third equals 5 to the x. Pull out those exponents, and now we can get x. The same idea might look like something like this, where it has 4 to the x equals 2 to the x minus 3. Well, we can break down 4, but we can't break down 2. We can break down 4, so now it's 2 to the second. We're going to put that in parentheses. And then what you're going to do with your exponents after that is you're going to multiply them. So 2 times x, which is now going to be 2 to the 2 times x equals 2 to the x minus 3. Pull out those exponential points. 2x equals x minus 3. Subtract x on both sides, and x is going to equal negative 3. And so this is when it kind of has become confusing, and that's why I wanted to do this with you right now. Again, we're looking at 9 to the x plus 2 equals 27 to the x. Well, I know that we can break down both 9 and 27 into 3. And so reality, what I recommend you doing is factoring trees and set up 9 and 27 in factoring trees and see what your prime numbers become. And you can do something like this. Multiply that 2 to the x and the 2 to the 2, 3 to the x to get 3 to the 2x plus 4 equals 3 to the 3x. Combine like terms, and you'll get x. I'm about to run out of time, but I have one more little thing